All right, welcome back. So up to this point in our journey, our Python scripts have been, well, pretty simple. They just run from top to bottom doing the exact same thing every single time. But you and I both know that's not how real network engineering works. Not even close.
I mean, think about it. Your job as a network engineer is all about making decisions, right? You look at a device and you think, okay, if this is a Cisco box, I need to run this command. But if it's a Juniper, I need a totally different one. Our basic scripts can't do that. They're just blindly following a recipe.
And that, my friends, is exactly what we're here to fix. In this explainer, we are leaving those simple linear scripts behind. We're going to give our scripts the tools they need to build a real, intelligent logic right into the code.
Okay, so let's get right into it. This brain we're building, it really comes down to two main ideas. Conditionals, your if and else statements, and loop controls, which are break and continue. These are the things that are going to make our automation smart, safe, and way more efficient.
So, we're going to start with the most basic building block of decision-making in, well, pretty much any programming language. This is how your script learns to answer a simple but powerful question, yes or no.
And that, of course, is the if-else statement. The best way to think about it is like a fork in the road for your code. The script gets to a question. If the answer is yes, or true in Python terms, it goes down one path. If the answer is no, or false, it takes the other path. It's really that simple.
Okay, now check this out, because this is a perfect real-world example. We're checking if VLAN ID 100 is inside our list of allowed VLANs. The script asks the question, is 100 in that list? The answer is clearly no. So, the code completely skips the if part and jumps straight down to the else block, printing out that alert. It's a simple but super effective security check.
And this is the key thing to remember. That else block, that's your safety net. It's your default action, your fallback plan. It's designed to catch every single scenario that doesn't match your if condition, which is absolutely critical for writing robust code.
But let's be real, how often is networking a simple yes or no problem? Almost never, right? You've got multiple vendors, multiple models, multiple situations. So what happens when you need to handle more than just two possibilities?
And that's where its awesome cousin, elif, comes into play. It literally stands for else if, and it lets you chain questions together. The script will ask the first if question. If that's false, it moves on to the first elif. If that's false, it moves to the next elif and so on, until it finds a condition that's true.
And this right here, this is a problem every single one of us has faced. Different vendors, different commands. So our script checks, is the device OS equal to iOS? Nope. Okay, moving on. LF, is the device OS equal to Junos? Yes, it is. So it sets the command to the correct Junos syntax, and this is the important part, it stops right there. It completely ignores the else block because it's already found its answer.
And that's the magic of it, really. You could have a dozen elifs stacked up, but Python is super efficient. The instant it finds the first condition that's true, it runs that code, and then it just jumps out of the whole if, elif, else structure entirely.
All right, so our script can make a decision before it does something. But what about making decisions in the middle of doing something? Say, inside a loop. Well, for that, we need two very cool new tools, what I like to call the skip button and the eject button.
So first up, we've got the skip button. In Python, we call this continue. Picture this. Your script is looping through a list of items. When it hits the word continue, it immediately stops what it's doing with the current item and jumps right back to the top of the loop to grab the next one. It's perfect for filtering things out.
Let's put this into practice. Say we're writing a script to configure any interface that's currently down. We loop through all our interfaces. The very first thing we do inside that loop is ask, is this interface's status up? If the answer is yes, we print skipping, and then we hit continue. That word immediately sends us back to the top of the loop for the next interface. The configuring line down below is never even reached.
You can see exactly how this plays out here. We check G1, it's up, so we hit continue and skip it. Then we get to G2, it's down, so we skip the if block and proceed to configure it. Then we get to G3, it's up, so we skip again. Finally, we configure G4. See? Continue lets us zero in on only the items we actually care about.
So the big idea here. Think of continue as your bouncer at the door of your loop. It's a guard that checks each item as it comes in and says, hey, do you meet the criteria? No? Okay, move along. It protects the rest of your code from even having to deal with irrelevant data. Okay, now for the other button, the big red eject button. This is break, and this one is way more dramatic. When your script hits break, it doesn't just skip the current thing, it terminates the entire loop. Right then and there, it's game over for the loop.
And this is all about being smart and efficient. Imagine you're searching a huge list of IP addresses for just one specific target. The moment you find it, why would you waste time checking the rest of the list? So in this code, we loop through our IPs. As soon as we find a match, we print found it, hit the break statement, and bam, the loop is done. We never even look at the remaining IPs.
Okay, let's put these two side by side, because you absolutely have to know the difference. Continue is the filter. It just skips the current item, and the loop happily keeps on going. Break is the stop sign. It exits the entire loop, and that's it. The loop is over. One is a scalpel, the other is a sledgehammer.
And this is why break is your best friend in a search operation. It saves time, it saves CPU cycles. It's just common sense, right? Once you have the answer you were looking for, stop asking the question.
So let's take a step back and just appreciate the awesome new toolkit you now have at your disposal. These aren't just random commands. These are the core abilities that take a script from being a dumb tool to an intelligent agent. So here it is, your new mental cheat sheet. You've got if-else for those simple binary choices. You've got elif for when things get complicated and you have multiple options, like different vendors. You've got continue, your skip button, for filtering out junk inside a loop. And you have break, your eject button, to get out of a loop efficiently once its job is done.
You now have the fundamental building blocks to create scripts that can adapt, choose, and react. Scripts that can handle different situations and operate efficiently. So the only real question left is, what are you going to build first? Next time, we're going to combine all of this stuff to build our very first complete configuration generator. I'll see you then.